Hey folks, Quill18 here, and welcome to a post-mortem for LUDUM DARE 44 Scrapitalism. So LUDUM DARE is or LUDUM DARE, if you prefer, is a 48-hour game programming competition. Well, actually, it's two competitions in one. There's a 48-hour solo competition. You have to be on your own. You have to make everything from scratch within the 48-hour period, all art, all music, all code. And there's also a 72-hour jam variant, so you get a whole extra 24 hours, which is a hell of a lot. It means 50% more time. You can work as a team, and you can use pre-existing, art and music and different things like that, kind of assets. And it's a lot of fun. And this is, I think, my 22nd time participating, something like that. There's two LUDUM Dares that I've missed. One that I missed outright, and then one that instead of LUDUM Dare, I did a program tutorial sequence instead. But we are back, baby, and we participated in the one with the theme was, so the way it works is the theme is announced Friday evening. That's the start of the competition, and the theme was "Your Life is Currency." And we actually had some really good ideas for like some really creative stuff, like some sort of weird like dystopian kind of corporate life simulation, right? Because like every year of your life to climb the corporate ladder and things, which I think is fantastic, and we'll probably explore it at some point. But I had a hard time sort of coming up with the actual game mechanic necessarily right off the spot. So in the end, what I did is a fairly straightforward side-scrolling shooter where enemies that you destroy will occasionally drop scrap that when you collect it, it orbs around you and acts as a shield or hit points or life, right? Your life. And then between levels, you can spend this scrap to purchase upgrades. So your life is currency. That was the interpretation. So every time you went in, you sort of had to like, how much of the scrap do I want to keep to maybe protect myself in the next level versus purchase upgrades, or more practically, because usually you want to spend a fair amount of it on upgrades, but in practice it's every time you get hit, not only you lose a hit point, but you're losing an extra $1 that you can spend on upgrades. So it makes getting hit that much more painful. So in this post-mortem, what we're going to do is we're going to look at the project. We're going to look at things like what went right, what went wrong. We're going to try to dissect some of the code and that kind of thing. One of the things with the compo variant of the LUDUM Dare competition is that the code has to be uploaded and made publicly available to view. You don't have to open source the code. It just has to be viewable. You can retain all rights and things like that, but there you go. I did upload this code under GPL, so it is open source. So if you want to use some of this stuff and whatever, it's there. This was made very quickly, so as we go through the project, I will talk about how certain things that were done were not necessarily, the greatest coding standards, but because it was only me alone and it was only over 2 days, it meant I could keep all the code sort of like uploaded into my own brain's RAM, so I could keep track of things fairly easily. Whereas if it's a longer term project, or if you're working with multiple people, that doesn't work. So it becomes much more important to like encapsulate things and protect things and things like that. But this was, it's the interest of speed. We have to go fast. Like Sonic here, we got to go fast to make the project go. So what I'm gonna do is I'm gonna play a little round here so that you can see how the game plays, and then what we're gonna do is pretty much look at all the individual little code files in here and talk about how this works. And yeah, you can download the project yourself. You can follow the link down in the doobly-doo to the GitHub page. You can fork it. You can make changes. You can do all that kind of jazz. So right over here, controls are very simple. You can use WASD or the arrow keys to move around, and spacebar shoots. You can hold it down if you would like. So we've got these little, the initial, the first level here gives you 4 pieces of scrap that you can pick up, although because they have slightly random motion, you might get bad luck. You might not be able to pick them all, but they've got, this first little set of scrap has the pick me up here. So it's sort of, there was no major tutorial or introduction screen to this. It's just like pick up, and then as soon as you pick up, it does bring up a little tutorial window. You got scrap. Scrap will shield you from damage, but it can also be used to buy upgrades from shops between levels. Click to continue. So we're going to try to grab as much of this as possible. So we've got ourselves 4 scrap here. And I know we've got the volumes quite low in this recording, but I really kind of like the sound in this project as well. As per usual, all the sound effects were basically made with just my mouth. Plus, there was one of them that was made, 1 or 2 that was made by like clanging together, I think, a plate with a rock for like sort of a ping, ping, clang, clang kind of sound when you hit an enemy that isn't killed in one shot. So you'll hear that sound effect later. So here's the shop. We currently have 4 scrap. We've got some random upgrades over here. Most of the upgrades start at 1 cost, some start 2, and then every upgrade you buy, the cost of that upgrade doubles. You get to see 3 upgrades at random. I think there's about 12, 15 different upgrades that are possible, and every time you buy one, it'll sort of recycle or randomize that button again, so you'll see what you get next, and you can also re-roll these choices here if you're not happy with them. So we can spend a scrap, say, on some homing bullets, and you can see it replaces there. We could unlock bullet time, so this is the ability to slow down the world. I'll go ahead and unlock this just so I can show off the effect over here. We'll leave the fire rate there. I'll keep 1 scrap as a bit of a shield buffer, and then we'll see what we do next. So once we load in at the bottom right corner, there we go. So we've got our little bullet time icon. You can also pick up mega bombs, and the first time you buy either bombs or bullet time, you do get 1 reminder little pop-up here that let you know the mechanics of it. It does bullets and bullet time charges will automatically refresh every level. Yeah, so you can spend this. Like, you may as well spend your bullet time this level because you will automatically get it. What you're buying in the shop is basically increasing your capacity for bullet time or bombs, and you'll be fully reloaded every single level. So it's B and T for these. Maybe they're the best hotkeys, maybe they're not, I don't know. But that's going to be okay. I'll try to use bullet time at some point in here. Clear through these waves. So this level, oops, I got hit and lost some scrap, although I did that totally on purpose to show you what that looks like. That was totally intentional. We got these little wiggly wobbly things. I'm gonna hit T for bullet time. Yeah, so we get a little shader effect. Time slows down, except for your movement. Your ship's movement is the only thing that's not slowed down during bullet time. Your own bullets are slowed down. Maybe you could have changed that so it didn't. So that was the end of that level. The levels are fairly short, partially because in LUDUM DARE, I try to aim for a game that can be sort of fully experienced within about 5 minutes, because people are trying to judge a lot of different games. You get like a couple of thousand submissions to excuse me, to LUDUM DARE, so people don't have that much time to spend there. Plus, I wanted the shop to open up as often as possible here. So we only ended up with 1 scrap. We could upgrade with piercing so that we have a chance of our bullets passing through enemies. Like, it still damages the enemy, but might hit someone behind them. I'm gonna leave it there and just go into the next level over here. Notice the heat meter at the bottom left, which does not seem to be doing much right now, and that's by design. Your regular initial bullets here do not generate much heat. Overheating is not a problem at the start of the game, but once you upgrade your weapons, in particular, specifically with multi-shot, but also I suppose fire rates and things like that, heat, does become more and more of a problem. Actually, basically as soon as you get your first level of multi-shot, heat management becomes something you've got to be concerned about. And I was trying to dodge that bullet, but as a result, I missed some scrap.
Buy these things.
But there are some upgrades you can get to reduce that. Okay, we can get multi-shot over here, very nice. Oh, we get a little drone bot too. I'm gonna grab that because it'll showcase that, which will be good. There's your improved heat sinks. You know what? It's risky because I'm gonna go into this with 0 scrap, but I'm gonna get that to try to offset the heat from the multi-shot. Most likely, we can still overheat if we just shoot continuously, but we'll see. But now we have a little drone that hovers around us and will fire bullets at the enemy. The drone will aim the bullets towards an enemy, but the bullets don't seek. They could still miss, but it does a pretty good job. Your drone has a few hit points. It can take a couple of hits. I think actually it takes 3 hits to kill it by default. Come in here. You'll see a little drone buzzing around. There it goes. And then I've got my multi-shot here. Nope, the drone already died. Poor little guy. Game over. Oh, and I game over here. We didn't even see the boss. Well, that's too bad. Then we got a little death screen, but that's okay. It was totally intentional for me to die this early because I wanted to be able to go into the code. Yeah, that's true. It's not just because I'm really bad at my own game. I don't think I've beaten my own game. Other people have, but that's pretty standard for LUDUM DARE for me to make a game that I can't necessarily beat, but that other people do. So, we've got 2 scenes in the project. We've just got a main menu screen over here that we don't really need to talk about. We'll open up the sample scene instead, which is this layout here, and then we'll go and dive into the code. In the scene itself, very few things are in the scene by itself. We've got the main camera. We do start the player unit in the scene right away. Of course, you could spawn that in, but it's there. We don't have anything with multiple lives here, so we never had to worry about, working out the logic to respawn the player or anything like that. You have 1 life, just you end up with, multiple hit points, right? I have 1 object that is my world manager, and I apologize for the fact that this is going to be pretty tiny. I'm on a really high-res monitor here. I'm currently in Scotland, and it's on a pretty high-res monitor, so the text here might be very, very tiny. At least in the in the code window over here, I've embiggened the font a little bit, so it should be a little easier. And again, you can download this project. Maybe you want to pause, download the project, open it in Unity so you can follow along at this point. So I got a world manager over here, which has a world manager script on it. So this is sort of like the global set of things that, you know, a lot of other pieces of code refer to. We've got a child in here. This is our container for our levels, and we have a level setup script, and we'll be looking at that. Spawn spots over here is just a... Let me move this over like this. This is just holding a set of prefabs over here. So there's no code on spawn spots. There's no code on these prefabs either. But if we zoom in here, and if I do something like this, oh no, it doesn't actually show you. See those little circles here? If I go around, you can see there's different areas. This is just, I use this in my level or my enemy spawning stuff. These are places where enemies can show up and spot and spawn. We got a canvas here with some various UI elements. The damage flasher, we'll talk about that. Little stats thing, upgrade windows, tutorials, game over, and a little menu when you hit escape. Event system is just required by the UI system. We've got an upgrade manager as well with just a single script on it, and that just helps keep track of when the upgrades come up. This has the list of all the upgrades in them and manages their cost. And then we have the Starfield effect that you might have noticed in the background. I'll hit play over here. It'll actually be quite cool because you'll see it in the oh, hold on, there you go, zoom in over here. You can see the stars in the background. These are all individual little objects. I think it's in the code. I think we have 250 stars that we spawn in random spots. We give them a slightly random direction and speed, I should say. And then when they reach, I think, 1 unit left of the screen, they just warp around over to the right. I suppose what I could have done when they warp over to the right,
Quill has wares if you have the
scrap. Y position here, but you don't really see the repetition just because there's so much stuff going on, which is so that's perfectly fine. Let me turn off that, and then I've got a sound manager over here. This is a thing I do if you take a look when we start playing it, just because like I want multiple sound effects playing, and each sound effect, I mean, there's the play one shot and different things like that. There's different ways to do it. Go into the sound manager, audio clip player. So what happens here is every time there's a sound, I just spawn a little audio clip player that then, well, sort of despawns itself when it's done playing. Although in fact what we do is we use a pooling system, and that lets you play an arbitrary number of sounds. There's just a little thing that I do it. It may not be required the same way now that the sound system in Unity has changed a fair bit, but we'll see. Okay, so that's just the sample scene. So now let's dive into the code, and I may go through the code more or less alphabetically, but what I want to do, actually, I'm gonna close all these. I guess they're all going to get open, doesn't matter. I want to start with the world manager over here. It's the first thing we're going to look at. And then we might go to unit or something like that, and then we might just go from top to bottom at that. So this is our world manager. We just have the one. We sort of do the sort of Singleton-ish kind of thing. Basically, we have a static, words are hard, a static reference. Where is it? Static right here, static public world manager instance, and then when we start this up, or rather when we on enable, we just set instance to this. And you can be a little bit more careful about this and wrap it in all kinds of different ways. But again, you know, we have a lot of stuff that's just public in here in the interest of speed for different reasons. But basically, it lets us the rest of the code, and a lot of our code needs to reference the world manager to check some various globally things about the state of the game. Like whether or not the game is paused, for example. So a lot of the code needs to be able to get a handle on our world manager. So this way they can just go world manager.instance.blah rather than doing, you know, a game object.find kind of thing. So it's very fast and it's very convenient. We also note what the screen bounds are over here. So we want to know how big the screen is, because a lot of things sort of despawn or wrap around or whatever when they're off the screen in some fashion, and the player has to be restricted to the screen as well. So we use this for a few different things here. Note, so we've got some on enable and start over here. There's a difference between on enable and start. On enable runs the moment something becomes active in the scene. The moment, like if something was every time you set active true on an object, or it becomes active because it just instantiated or because a level just loaded, this runs immediately. Start runs right before the first update of an object. So onEnable always runs first because it runs the second the object sort of exists in the world rather than just before its first update. And when things are referencing each other, the onEnable timing becomes kind of important because like, let's say something in its start needs to do something with World Manager. Certain things need to be already set up on the World Manager before that goes. In particular, the instance needs to be set up and the screen bounds as well. Worth noting, onEnable runs every time you set, if you toggle set active to false and true, false and true, false and true, onEnable will keep running every time in there. So there's different caveats. Anyway, there's that, and then, we just grab, we find the player unit because we assume there's a player unit in the scene at the start. We find it right away and then just keep a reference to it. And then, yeah, we have an object that is our level setup. So that was in our scene over here. If we go to our World Manager right over here, we have something that's got the level setup component on it. There's just one in the scene. So we find it over here and we tell it, hey, go ahead and initialize your levels at this time, please, and thank you. And we find a reference to this level parent. It happens to be the same object. In this case, the object that's got this level setup on it and the object called levels is the same, but it doesn't have to be, so we grab that. I keep this level parent around because what happens, and we'll look at that when we get to our level setup script, is this level setup script will create a bunch of level objects below this, and then the World Manager just turns on the appropriate level object depending on what level you're on. There are 18 levels in this game. And then, yeah, we start the first level over here. Boom, done. We've got a bunch of things that we keep track of. A lot of these are like, like things that we want to expose in the inspector over here. So a bunch of things that we fill out, various prefabs, so a few different settings and things like that. Some of these things are public just because we track it. Certain things, for example, the number of enemy spawns, enemies killed, amount of scrap collected. Really, this should not be a public integer. Really, you should have an accessor function or something you call to just say, hey, we killed another enemy or spawned something else instead of being publicly visible like this, but speed/laziness for the purpose of LUDUM DARE. All right, so update code over here. And I mean, I won't necessarily go through every file line by line, but most of the files are actually really short, so it'll be easy to do. In our update, we check to see if someone's hit escape. If so, we open the menu, which also pauses the game. If the game is paused, we just stop running at that point. Otherwise, we increment. So bullet time. This is the slow motion vision where the screen sort of inverted itself. We just count down the timer. We turn things on and off as needed. And if the player unit is now null, that means the player is dead, and we call game over. Little helper functions. Hey, to start bullet time, we start it for a certain amount of time, and we tell the bullet time special effects that it should be visible. Oh yeah, I don't use a lot of coroutines. I've talked about it before. I don't know why. Like, for some things, coroutines are handy, and for other things, there's better versions. Like either start firing off a thread, or maybe it's something that can just run in like an update function or something like that, where you might have a little bit more code, because coroutines kind of run internally on the magic of Unity to a certain extent. But here's our Mega Bomb effect, which I didn't actually showcase in the game. Let me go ahead and hack something here. I'm going to take my player and I'm going to give it a couple of Mega Bombs and a couple of bullet times over here. Just set the maximum, because when you go into a level, let me change the view over here. So we spawn in, we've got our little icons over there, and if I hit the Mega Bomb, what? Null exception? What? Oh, that's interesting. Okay. If you try to launch a Mega Bomb when there's no enemies on screen, we get a slight error here. If enemy unit dot all enemies not equals null. So it probably won't be an issue in the game. It doesn't break the game. The only downside is you don't get the bomb effect, the bomb visual, if there's no enemies on screen. So if we just wrap this, then it will no longer try to kill the enemies with the Mega Bomb. Yeah, I don't think I'm gonna care about. This is not a fix we need to worry about for LUDUM DARE itself, because you won't have Mega Bombs before enemies get spawned anyway. And it's not that it doesn't work if there's no enemies around. It's if there's never been an enemy spawned, the Mega Bomb wouldn't work. But if I hit B, we get this little screen shake effect and some little explosions all over. And yeah, anyway, okay, so back over to World Manager. So we have a coroutine here because we fire off the explosions and shake the screen over a few moments, which is what's going on over here. So in the coroutine, we shake the screen a little bit, and then we wait for like 0.05 seconds between shakes, and then we sort of rattle it down. That's going to be okay. Here, just the references. Are we currently in bullet time? What happens is a lot of our code, rather than using time.delta time directly, it inquires about the current bullet delta time, which either returns the true delta time, or if it's bullet time, we do 1/3 of that, so that enemy motion and everything like that, and cooldown timers and everything goes down at three times slower than real time. Roll scrap. This is just something we call every time we kill an enemy. We roll a random chance to see if we got scrap. So by default, I think the base scrap chance currently is set to 10%. So there's a 10% chance every time someone dies that some scrap loot might get dropped, and we just spawn it over here. We're spawning it using simple pool. This is literally, if we did instantiate, this would work exactly the same. With simple pool, and this is a very tiny piece of code, very simple little script that I have written and published. I think it's like 5 years old at this point. It's available on Gist, like GitHub's Gist, and you can download that. It does pooling. What pooling does is every time you sort of create and destroy an object in Unity, there's a little bit of overhead. There's a bit of overhead to creating something, and destroying something also has a little bit of overhead because the garbage collector system runs later on, which can cause the code to just sort of hitch and delay for a tiny bit. So with pooling, what's going on here is like the first time it will instantiate a new object, but then when we destroy the object, and we destroy it by calling simple pool.despawn, it doesn't actually destroy it. It just sets it to be inactive. And then the next time you try to spawn an object, it checks to see if we have an inactive version of that object, in which case it just makes that old one active again, and that stops things from being spawned and despawned. And it's not important for things where there's not that many around, and they're not spawning and despawning that quickly. But in particular in this, there can be a lot of bullets flying around in the late phases between your multi-shot and the enemies get multi-shot later on, and all kinds of stuff like that. And so the bullets use the spawning system here so that we don't continuously instantiate and destroy these bullet objects, which is quite nice. So that's all that's happening here. And then we give it a random graphic from our list of sprite graphics. We have some explosions that we can do, small, medium, or big. The small explosions don't actually do anything. I don't know if this gets called. It might get called, it might not, I don't know. I think this may have been tied to like when bullets expire, they might do a small explosion, but we actually don't have it do anything. We just had placeholders in case we wanted to do that. So we have little prefab explosions. And then at the end of the level, we turn the current level object off. We pause the game. We check to see if the game is over. So if we've reached the final level, then we show game over here, that's fine. Otherwise, we increment the level, we show the upgrade window, and we play a sound for the shop. So we have the sound manager here that has all of the references to our various sound clips, and then spawns those little sound objects as well. When we start a level here, we close the upgrade window, we unpause the game, we make the player unit inactive here. We hide the player unit because what we do is we have a little warp-in graphic that plays, and then when the warp-in graphic is done, the player becomes active again. We then start this coroutine here, which is basically used to kill time until the warp-in graphic is done. So this is the start level coroutine here, and what it does is instantiates the teleportation effect. We wait 3 seconds, then we reset the player for the new level. This reloads your bombs, your bullet time uses, spawns your drones again. So it actually, what we do is we destroy all the old drones and respawn them again to make sure they have full health and everything. Then we make the player active. We tell the current level that it should be active, so it will start to spawn enemies. And then, yeah, we check to see, hey, have we already done the bomb tutorial? And should we show the tutorial window for that? So this is how we pop up tutorials. We pause the game, we make a window active, done. Pause, unpause, just sets a Boolean. On game over here, we pause the game, we show the end screen, and we tweak the text on the end screen to either say game over if the player died, or victory if they reach the end of the game over here. And yeah, we update some stats on there. Get current level, open window, close window. Okay, World Manager is by far the biggest. Well, it's probably tied with unit. So what we're going to do now is we're going to take a look at the unit code. Everything that you basically see on the screen, other than the scrap and the stars, is a unit. So the player is a unit, enemies are a unit, and bullets are a unit. The unit script over here is responsible for it started off as basically it just had this little velocity thing, and so the player unit code here is what listens to the the player's keyboard inputs, basically, space bar, arrow keys, that sort of thing, and updates the velocity appropriately. And there's also an enemy unit script over here, and it's responsible for just doing some basic AI, like this. In this basic example, the enemy just moves forward and tries to shoot whenever possible. And whereas the unit itself is responsible for moving stuff around. So, in the on enable, it's very important to have on enable because of the spawn despawn thing. So one of the things, if you're using a simple pool, which is making objects active and inactive, start only gets called the one time ever on the object. So when you make an object inactive and then re-enable it afterwards, start doesn't run a second time, but on enable runs every time. So this has to be, just run and clean some things up over here, is dead equals false, for example, that sort of thing. So a variety of things, again, possibly more public than we need, although a lot of these are actually exposed to be able to tune it. So you can see the unit script over here on our player has got, things that we are exposing so that we can adjust it in the prefabs and whatever over here. So we've got that. We do we have a funky little thing in here so that a unit knows if it's a player unit or not, and it basically does it by checking to see if it's got a player unit component on our cells, in which case, my player unit will either point to a player unit component, or it'll be null, whether it's a player or not. We have a duplicate, this bullet delta time function over here. If we're a player, we only return the true delta time. Otherwise, we return the world manager's bullet delta time function that we just talked about, so we may move in slow motion or not. In the fixed update runs on every physics tick as opposed to every visual frame of the program, which can be different. If the game is paused, we just return right away. Invulnerability, if you get hit, if the player gets hit, the player is invulnerable for a half second or something, so we just update the timer and do things like that. Because this code is shared by a lot of different things, so we have this homing turn rate. This is a behavior that causes the object, the enemy or the bullet, to try to home in to a target. So we say home to nearest enemy. So if the player has upgraded their bullets with homing behavior, this will run. Or if it's an enemy that for some reason chases after a player, this would run. That is actually, there's no enemies in our final build that does that, but it could have. So this is effectively only used for bullets, but it could be used for all kinds of different things. We have the speed of the homing or the homing behavior decay over time. So you home, well, there's a Boolean for it, but so bullets turn towards the player, say, very aggressively at first, and then over time turns less and less aggressively. And it means that the bullets will end up moving towards the player, but be dodgeable in the end, and look like if they pass the player, because by that point the homing rate will have decayed, it looks like once they get past the player, they don't bother homing anymore, which looks quite nice and is very satisfying. Then we just move our position over here based on our velocity, modified by the bullet delta time. We are modifying the rigid body 2D over here. All the units have a rigid body 2D set to kinematic mode, like they don't move via the physics system. There are no true collisions in here, but we use, we've got hitboxes and collision boxes and stuff like that with triggers. So they all have rigid body 2Ds. And in a sense, updating the transform dot position and the rigid body 2D dot position in the end more or less does the same thing. But we found there's some very funny stuff that happens if you update the transform dot position twice in the same frame. One of them, and you have a rigid body component, one of the position changes sort of kind of gets ignored. But if you update the rigid body instead, it works better. And the reason this is important is because the home to nearest enemy, also likes to modify some of the position stuff over here. So anyway, there's that. We have a Boolean. Are we limiting the object to the screen bounds? This is only true for the player. So for the player, we keep it within the screen bounds. Otherwise, we check to see if the object is outside of the screen bounds, in which case we destroy it. There's a bit of a grace period here. I think things that spawn in have about a second or something like that to get within the screen bounds. And as we get down here, we also have like a buffer. I think they have up to a second to be within one world unit of being inside the screen bounds or something like that. Otherwise, they get destroyed. Invulnerability timer, and we alpha things out to make the player semi-transparent when he's invulnerable. In fact, in practice, I don't think it's transparent enough. I think one would brought this down to like 0.25 or maybe 0.1 even alpha, because at 0.5 you can't really tell that much that the player is transparent. But in practice, it just makes the game a little bit more forgiving. Even if you don't notice that you're invulnerable for a half second, you don't notice. I just realized we have an upgrade that gives you longer invulnerability time, and it's not actually being used here. Or no, that's right. It wouldn't get used here. It gets used somewhere else. Here's our homing behavior over here. It's a little funky. Homing skip frame over here. I don't have a note. I should probably put it in here. Homing is CPU intensive and doesn't have to run every frame. So what we do here is we have each thing do its homing calculations. This range here, because it's an integer, it's exclusive, so it's either going to be every 2 or 3 frames it calculates. And we do a little random here so that not everything is synced up all the time. Because the thing is, later on, what happens is the enemies get more and more and more multi-shot. And in particular, the boss, in the second phase of the boss, when you've blown off its outer arms, effectively, the center core starts firing homing bullets. And when it's got multi-shot later on, it spams a ton of homing bullets. And if they're all doing their homing behavior on exactly the same frame, it gets kind of rough. So by doing this, we spread out the load a little bit. So effectively every 2.5 frames on average is when the homing bullets home, and they get broken up a little bit here. So it helps the performance a tiny bit. We did some profiling at the end. One of the things with this game is it's not the most creative game in the world, and it doesn't have a ton of content. It has 18 levels, but a lot of them are sort of repetitions of previous levels, except we have a function in the game so that future levels, even if it's a copy of an earlier one, they're going to be tougher. Things are going to have more hit points, they're going to fire faster and multi-shot and do things like that. But what it does is there's a fair amount of finessing, like we and polish that went into it. Like we actually brought out the profiler to make sure that was running fairly efficiently, especially in the late game, because some people were noticing there was definitely some slowdowns there. So we spent some work making sure that it runs pretty smoothly, which I'm pleased with. We got some hard-coded like layer stuff over here, which isn't great. This is objects on layer 12. This is a bullet that's on the enemy team, so it wants to home into the player. A little bit hacky and not the way I would have wanted to do it. Or I would do it if I was writing it a little bit cleaner. I would probably, have some sort of actual flag or different mechanic like this to figure out the team thing. But there we go. So this is a bullet. This is the enemy bullet layer over here. So what we do is we try to home in on the player. This is the player unit. This is a reference to the player here. If it's null, it's because the player is dead, so there's nothing to do. Otherwise, we home to that player's transform. If we get to here, it's because we are probably the player's bullet. So we check to see this is an array of all the enemies that currently exist. If it's null, then we just bail right away because there's no enemies to track. Otherwise, what we do is we iterate through every enemy currently alive, and we check to find out which the closest one is, and that's the one we home to over here. And it's possible that even if enemy unit nearest isn't null, I guess we could have actually saved a little something by checking if all enemies equals null or all enemies.length is 0, then we can return there. But anyway, so then we home to that. So at this point, no matter if we're an enemy bullet, a friendly unit, or whatever, we've got some sort of transform to home to. So we just try to rotate towards it, which is what this code is. Yeah, we rotate towards it. And then what happens over here, our velocity gets tweaked so that we are going at the same speed that we're supposed to. The velocity of that magnitude, our speed is the same. But now we're going in the direction that we're facing. The transform.right is effectively the direction we're facing over here. Little function to make sure that we're within screen bounds over here. And or over here, if we're outside of screen bounds, we die. This is the code gets run whenever we take damage. We make sure we're not invulnerable or already dead. If we have subparts, so for a boss, if the object that's supposed to take damage here is the core of the boss, but it still has its arms, it won't take any damage. If it's the player, then we flash the screen red for like a quarter second to let them know they're taking some damage over there. And otherwise, yeah, we take some health damage. We reset our invulnerability timer. If our health is below 0, health 0 is fine. In our game, health 0 is a perfectly valid state for something to be in. Basically, health is like extra hit points or a damage buffer or whatever. So like even when the player spawns, he has a health 0. When the player has one piece of scrap going around him, he has a health of 1, or 1 money to spend. So 0 is fine. So if you go below 0, that's when you die. Otherwise, we took damage, we didn't die, so we play like a clang sound. Gain health. Here's our die code over here. Sometimes we call it with just destroy if we're just trying to clean something up, so there should be no effects. But yeah, if just destroy is false, then yeah, we roll on scrap. If there's scrap allowed, we increase the number of enemies killed. We maybe do some various explosions over here, play sound effects and whatever, and then we despawn the object. Now, even if an object wasn't spawned with Simple Pool, despawn in Simple Pool, it will just note that it wasn't actually a pooled object and we'll just destroy it instead of things. But yeah, there's a little bit of a gotcha that like destroy only actually happens between frames too. You gotta keep that in mind. Something's not truly dead until the frame is done processing, which can get you some gotchas, which is one of the reasons we actually set a Boolean over here to keep track that things are supposed to be dead. On trigger enter, 2D. So this is when two units collide with one another. They then do damage to each other. So again, bullets are units, enemies are units, players are units. So whenever two units collide against another, they do damage to one another. By default, the damage is 1. So if a player and an enemy collide with each other, they both do 1 point of damage to each other. And unless something has gotten bonus health from some reason, they'll both die. So you can look at that. We do check that pierce chance. So if the other object has pierce chance, we may not do damage to it. So effectively, if a bullet, which has pierce chance, hits an enemy, the enemy might not do damage to the bullet. We calculate it that way. It's a little awkward. You'd think of it more like the bullet won't take damage, but instead we don't inflict damage on something that has a pierce chance, so that it can keep going. Set fire rate, done. Okay, so that's the unit code over here. What I think we're going to do at this point is we'll start going through the code from top to bottom, because otherwise it would be very easy to miss something. So our bullet time effects. All right, bullet time. You saw it in the thing. Let me remind you. If I hit not pause, but play. Thank you. Go in here, and we just wait for us to spawn in. There we go. And if I hit T, this is the bullet time effect over here. This is just a post-processing image shader that runs on the camera. So on the camera, we have this bullet time effect script over here, and it just applies a shader. So on render image, so after the camera has done like rendering the entire scene, the entire screen is basically like just a big bitmap, a big JPEG kind of thing, if you want to think of it that way, of the screen. Well, that gets passed here. This is the source of the screen. So this is everything that's been rendered is here. What we do is we take the source, we copy it into this destination, and we pass it through a material. And this material has a shader effect on it. I guess we can do over here. We can take a look at the shader. All it does, this is literally when you create a new image shader in Unity, this is literally what you get. It just, as its example, it just inverts colors. So we're just running that. We thought, oh, we could do all kinds of cool shader effects, but shader coding is sort of its own little beast, and I'm not very good at it. I'd have to spend a lot of time just Googling some of the syntax and different things like that to make a really funky effect. It turns out just inverting the colors was satisfying enough, so we're running that. Part of me kind of wanted to do like a matrix sort of, I don't know, some sort of effect, right, for bullet time, but just inverting that's okay. So that's all we do. We just, yeah, when someone goes into bullet time, it turns it on and off. Here's our bullet time UI. This is literally just the number of little hourglasses you have in the bottom right corner. So if we go to the stats group, bombs and matrix, bullet time over here. So yeah, there's just a little square over here. It's just got a horizontal layout group, and what happens, this piece of code checks to see how many uses of bullet time are remaining, and then just instantiates that many icons in the list, and like or removes them if the uses have gone up. I mean, ideally, you know, you might not want to run this every frame. Instead, you might want to respond whenever someone uses a bullet time instance to change the graphics, but it's fine. So every frame it just checks to see what the current count is, and then updates the graphics as needed, and that's okay. Okay, bullet unit. This does nothing, apparently. I think if we go into our prefabs and we take a look at like a bullet, I think it actually, yeah, I think I was thinking the bullets would need special code, but the bullets don't. They're just a vanilla unit over here, nothing special, just the unit script, and that's all. So we could actually remove that and be okay. Here's a drone unit. The drones are the things that hover around the players. This code over here just makes it so that the what it does, yeah, it picks a random spot near the player and just tries to like do that, and then when it reaches it, it picks another random spot near the player. So the drones sort of bounce around the player. We could give it a little bit of an example. If we pop back to the player unit over here, and I give you, say, a max drone count of 2, and we hit play, the player will spawn in with 2 drones around it. You can see it sort of dancing around the players here. There you go. I didn't realize the drones apparently don't pause when we're paused. You can see as it moves, it tries to follow, and then it sort of hovers around. I don't know, I thought it was a very satisfying effect. And yeah, you can see the drones try to auto-fire at things here. So they aim, but the bullets don't home, so they don't always hit, but it's still pretty handy.
Game over.
And I was dead. All right, good. So that's it. That's the drone behavior over here. Enemy units. So there's a little bit more code here. The enemy unit script is fairly short, though. It's kind of surprising. What it does is it keeps itself, whenever it's on enable or on disable, it adds itself or removes itself to the all enemies list. This saves lookups, right? Because otherwise, if you want to be able to do something like homing bullets that, you know, target the nearest enemy, they would have to find all instances of enemy units and do that. And lookups of like, you know, so GameObject.find all of objects of type or whatever, those are sort of slow. So we just keep a nice little public list, a static public list of all enemies updated, so we can always find out who they are over here. I mean, ideally, we might not make this a public property. We might want to have some sort of accessor function for it, but, you know, LUDUM DARE, speed, single programmer, that sort of thing. We'll talk about weapon slots later on, but anything that can shoot has a weapon slot on it. These are set up as arrays because in theory, a dude could have multiple weapon slots, maybe with different types of bullets. In practice, in our game, that didn't end up happening, but by doing this, like there's barely any extra work to set it up this way, and it meant that if I suddenly decided that I wanted something to have multiple types of bullets on it, it would be as easy as just drag and dropping something else onto the prefab. So every round, are we paused? No. Otherwise, we do AI and then do shoot. So these are virtual functions over here because I don't use a lot of like inheritance and polymorphism in my games because, as we know, component design, like using a component system as opposed to an inheritance system for our classes, tends to be a great thing in game design, and in fact many other applications as well. Turns out it's just a lot easier, and this is where a lot of people are using, and it's the de facto way of programming in Unity, but as well as many other things. That being said, here we do allow you to subclass enemy unit over here and override the do AI, as well as the do shoot, although I don't think anything overrides do shoot. But the do AI is how we do the movement. So if you're just a normal enemy unit, all you do is move towards the left at your maximum speed. Very simple AI over here. And do shoot is it just it tells every weapon slot on it, hey, fire. And the weapon slot is responsible for managing cooldowns and whatnot over here. So every frame the AI tries to shoot if it can, and we have a little check. Do we have subunits over here? This is for the boss. So in the case of the boss, the core does not fire while it still has its arms on there. Okay, that's enemy unit. Done. Easy. And then we have some subclasses. So enemy unit linear actually has a vector 3 that we can set a direction. So we use this for our enemies that move diagonally. So they have a different direction that they move in rather than anything else. In a sense, I probably should have done something like, dot normalize times unit.max speed or something like that, but you know, so what, you just put in the vector, it's going to be fine. Here's an enemy unit that's got this is how we flag subparts. They don't do anything. This was important. The arms of the boss don't have their own movement. They're just a child of a parent, so we had to make sure that they don't move on their own. Here's an enemy. This is actually the boss behavior here, this up down. What it does is it comes in from the left of the screen until it reaches a certain X position, and then it moves up and down. So yeah, if we haven't reached the target X position, what we do is we keep moving left and then we return. Otherwise, we just move up and down within the screen bounds. Done and done. And we have a wavy unit over here, which just uses a sine wave to wobble up and down as it crosses over the screen. Heat meter over here, this is just for our graphic of the heat meter in the bottom left corner here. And all we're using is the image.fill amount here to do a cut. If we go into the canvas stats heat, there we go. Oops, open up, open, thank you. Go to the heat bar here, the fill amount, zoom, zoom, zoom. So that's it. That's how we manage the heat. All right, level, boom. For the level, what we kind of want to do, let me close a bunch of these, it'll make it a little easier for the next bit. Boom, boom. For the level, before we talk about the level, what we probably want to do is talk about level wave. So this is a very simple little structure. Each wave, so each sort of set of enemies that are going to spawn in on the screen are represented by a wave. They have a prefab. We spawn a certain number of enemies. This is the delay between each enemy that gets spawned. So, you know, we might want to just, there's a word I'm looking for, and I can't think of it, but just put a little delay between each one of these enemies that spawn. So if we're supposed to spawn 5, maybe we want to put like a quarter second between each one of them appearing to give them a chance to move. What location do they spawn at? This is the spawn offset. So this is the positional difference between spawning each enemy. So basically for each of these waves, either when there's a group of enemies, either we might spawn them with a slight delay, or we might spawn them with no delay in between them, but instead giving them a bit of a positional offset. So for example, when you've got a wave where they're coming in, the beginner waves, where you get like 5 enemies in a row that all move towards the left in one big line, they have no delay between them, but they're offset by like 1 world unit between each or something like that. And this is how long to wait after this wave has spawned, how long we want to wait before we do the next one. So the level over here, it's just got an array of these waves. It keeps track of what wave we're on and various timers and things like that. And basically it just goes through and, you know, delays for various things. This is probably better over here. You know, do we still have to spawn some dudes? And if so, we spawn the next wave of enemies over here. And then we've got some timers to like wait for like the end of each wave or even at the end of each level over here. There's just some little pauses and then we checked it. And at some point we say, hey, this level is over. We tell the world manager we are donezo over here. Spawn next, yeah, just goes to takes a look at the current wave number, takes a look at the enemy prefabs, and then spawns as many as needed. We've got this modify enemy by level here. Basically, depending on what level we are, we give the units a little bit of extra health, and we also tweak their fire rate, as well as perhaps give them the ability to have multi-shots. So starting at level, well, when the level variable here has reached 4, which is effectively level 5 in the game, because the first level is the 0th level, then they start firing multiple bullets per volley, which gets to be pretty dangerous. So yeah, the level script is responsible for spawning waves of enemies. And then we have the level setup over here. This is how we actually create the 18 levels that are in the game. And this, in theory, would probably be a text file. This level setup would probably, in another type of project, read from a text file that could easily be tuned and customized. But yeah, what I have is I have 5 different versions of levels. So level 0 through level 4 over here, and all they do is, so level 0, this is the first level you'll see in the game. It creates a new object called level 0, and it adds a level component to it. And then this level has a number of waves, which we'll create over here. We could have done all this through the inspector, and that's what we were doing before, but I found it a little annoying to work in the inspector and do, copy and paste and work very quickly. So it turned out to be easier here. So this level 0 has 3 waves. Technically, the first wave is scrap, right? At the start of the game, it spawns 4 pieces of scrap that you can pick up. And so we can introduce that mechanic. Then we spawn 2 waves of enemies that move straight forward. It's these straightforward enemies. We just spawn 2 of them. We have no delay between them, but we offset them by 1 world unit downwards from their spawn. Boom, boom. So 1 spawns at front plus 1. So front is like directly front and center. Front plus 1 is a predefined spawn spot that's slightly higher than center. So I have spawn front plus 1 and plus 2, as well as front minus 1 and minus 2. So we do that, and you can see that we just keep going through these various levels. We have different waves of things, you know, diagonal downwards, diagonal upwards. So they just spawn the correct prefab at the correct location, and that is that. So that's how we set up the world in there. The Mega Bomb user interface, this is just, part of the UI. Same thing as the bullet time. It just makes sure there's a correct number of icons to represent how many Mega Bombs you have. So the player unit script over here, this is just attached to a player. And it's mostly responsible for handling the player's input. It does have, it also has various other publicly exposed things in the inspector for things only the player has, like mega bombs and bullet times and how much drones, as well as the current state of the upgrades of these, drones. So they get bonuses to their armor and whatever, things like that. This scrap limit, you can ignore this. Originally, it was going to be a thing where this was going to be quite low, like start at 5, and if you had more than 5 scrap around you, it would slow down your ship or do this or that. It turned out to be kind of unfun, so I just raised the scrap limit really high. I didn't remove the mechanic. Technically, if you have more than 50 scrap orbiting around you, you will start to slow down. In practice, you'll never see that. A little boolean to know if this is the first time we've picked up a scrap, because if it is, we show the tutorial. But yeah, here's how we pick up the scrap. What we do when we pick up the scrap is our health goes up by 1, and then we have the scrap shield around us, which is the visual of the scrap orbiting you. And so we tell it that we're gaining some scrap over there, and we play a little slurp sound. Count, over encumbered. Here's our update per frame. Are we paused? What's our speed? Here's our over encumbrance code, which again could basically be ripped out because it basically doesn't do anything anymore. Here's where you get the inputs from the player, get axis. So this is mapped to WASD and the arrow keys by default, as well as the joystick axis, technically, if you're doing that. We check to see the state of the fire button, which is mapped to the space bar, if it's being held down. So this is not get button down, this is just get button, which returns true if it's being actively held down. While it's being held down, we try to fire all of our weapons over here. If we hit B, we launch Mega Bomb. If we hit T, we launch bullet time. This is every level. Reset for new level gets called, which just resets our Mega Bombs, bullet times, as well as spawns our drones. When we hit the launch Mega Bomb, here, this to-do could be removed because we actually do have the effect that happens right down here. So when we launch a Mega Bomb, all enemies that exist take damage equal to the Mega Bomb damage, which I think starts at 3. And enemies start with 1 HP. They do scale up in hit points though. Mega Bombs but Mega Bombs are quite nice, and you can increase the damage of the Mega Bomb as well. And then we tell the world, hey, please play the Mega Bomb special effect. Bullet time over here, we just make sure we just start bullet time right here in the world instance, done and done. And then we have these upgrade functions. So we'll talk about the upgrades later, but basically when an upgrade gets launched, it calls the various upgrade functions on the player, which is responsible for tweaking things. So things like improving our fire rate, we actually go and modify each weapon slot and give the weapon slots fire bonuses and things like that. So there's a bunch of little things, update functions, they're pretty simple. And there you go. So that's the player. Here's the scrap. So this is when an enemy dies, sometimes it drops scrap. All it does is the scrap moves towards the left side of the screen because you're supposed to sort of be moving forward, but it's got a little bit of randomness. So different scrap moves at different speed, as well as might have a little bit of upward or downward movement over here. And then every frame, the scrap checks to see if it's within pickup range. The player has a certain pickup range over here. We just check to see if our distance is less than or equal to that. If so, we tell the player, hey, pick me up, and then we despawn ourselves, done and done, and then we move ourselves over here. The scrap shield, this is just responsible for orbiting scrap graphics around the player. Even though it uses the same graphics as the scrap itself, these are not instances of the scrap class. So every round, what it does is just orbits. It sets the rotation over here. We check to see how many hit points the player actually has and see if that matches how much scrap is around the player. So we either gain or lose scrap by doing that way. So if the player is taking damage, lose scrap, for example, here, what it's going to do, it's going to spawn this scrap debris prefab. So this is again, it's not real scrap. It looks like the scrap that sort of flies off from your ship and phases and fades away, but you can't like pick it up or anything like that. It's just a visual effect. So we just remove one of the scraps that's orbiting us, and we spawn another piece of scrap instead, the scrap debris, in the same position, and we have it fly away. The gain scrap function, this old gain scrap, normally doesn't run. All it does is this is just simply going to spawn a piece of scrap in the shield and do that. Instead, in practice, it's this gain scrap here, which has a reference to an actual piece of scrap. The piece of scrap that is being picked up by the player. We do this because what we do is we look at it, because there's more than one sprite. There's a few different, I think there's 3 variant graphics for the scrap. We grab the sprite from the actual scrap and use that for the piece of scrap that's going to be in the shield. We also make sure the locations match. So what happens basically when you pick up a piece of scrap is where the scrap was, we spawn this visual thing that's going to be part of the shield in the exact same location, destroy the old one, and then the new visual piece of scrap then just floats into the correct position to start orbiting around the ship. It looks very cool. And here's our rotation. So we just go through all of our children here in the shield, and rather than set its location directly, we lerp to the correct location. And this in particular is really nice when you pick up a piece of scrap because it smoothly joins the rotation pattern instead of jumping in. It looks really good. Self-destruct, so this is a piece of code that I use quite often in lots of different applications. It's very simple. It's got a lifespan and a fade out time as well. And all it does is, on update, it just counts down its lifespan. If it reaches 0, it destroys itself. If the lifespan is under the fade out time, then it starts to do a bit of an alpha. So let's say your lifespan is, say, set to 2 and your fade out time is set to 1. So for 1 second, so as it counts down from 2 seconds all the way down to 1, nothing will happen. As soon as it hits that 1 second remaining of lifespan, it will start to fade out. And once the lifespan hits 0, then it will just destroy itself and remove itself. Very handy little utility function, or a script. I use this all the time in all kinds of different programs. It's handy. Little simple move script over here, something else I use a lot. You just drop this component onto an object, you give it a velocity and maybe rotation speed, and it either moves on its own or rotates on its own for whatever reason. Done and done. Next is a simple pool over here. I've done a video specifically for simple pool on the channel. Again, you can get it from my GitHub gist over here and download this. But instead of calling instantiate, you call spawn. Instead of destroying an object, you use despawn, and it just works with the caveat that awake and start only run once per object. I gotta remember awake as opposed to on enable sometimes, because awake I think runs before on enable, but only one time. So yeah, you should reset your object after calling spawn, either do things in on enable or have an explicit function like, to init the object after you spawn it this way, just to reset everything properly. But I won't go through this because we've done it on a video and it's very commented, as you can see. Here's a Starfield effect, which looks really good, right? If we start this up, boom, hit play. We got our Starfield back here, which looks really nice. So what it is for the Starfield is there are, I believe, 4 different objects in the Starfield graphic. There's a sort of larger square, a smaller square, this X, and the little cross over here. And what we do is we are creating, I think this is set, 250. We instantiate over here 250 star objects. We give them a random position on the screen. So again, here the screen bounds there. We give them the stars a random starting position on the screen. We also give them a random color. So random.color HSV will generate a random color. There's a bunch of different variants of this function. You can just call it by itself, or you can call it with various parameters to set a range of its hue, saturation, and value. That's what HSV stands for. So hue is the color from 0 to 1. So if you limited it, you would only get, say, red bits or blue bits or something like that, different shades of blue, different hues of blue. But I do the whole thing. So we've got the whole range of color. Next is a saturation. So saturation is more colorful versus more black and white. So if the saturation is 0, it'll effectively be gray. Like it'll be somewhere between white and black. So if your saturation is 0, then your hue doesn't matter really. And then there's value, which is how much color, how much brightness basically is the value over here. So we have the full range of 0 to 1 for the hue, the saturation. Those look good. So we get scars of absolutely any color there is. And then the value We keep it here so it's somewhat muted. It's not super bright, and it looked about right over here. I was pretty happy with it. So yeah, we give it a random position, and we also instantiate it with a random speed over here so that the stars go at different speeds, which gives you a bit of a parallax effect, which looks pretty good. Now, rather than the stars, so we're just spawning a game object and giving it a sprite render, and that's it. The stars themselves don't have any code running on them whatsoever, which is quite nice because there's 250 of them. We don't necessarily want 250 different updates to get called because there's overhead in that. Instead, it's much better to have one update over here in the star field that then loops through each stars. There's various things with like memory management and different things that you could optimize and do different things. I mean, by having a single update as opposed to 250 updates, we're already improving a little bit of the memory management, but there's even more things we could do if the performance wasn't great. All we do is we loop through all the stars that we have in our array, and we just move them to the left. And if their X position is too small, as in it's gone off the left side of the screen, then we loop it around to the right hand part of the screen so it can keep going over and over. And that's it. Very simple. I got these stats 01, 02 pieces of code because I thought I was going to be arranging things differently. But all this does is update a couple of UI elements on the screen. Your scrap counter, and I think this is your current level counter right over here. Yeah, that's all. The unit script we've already looked at. Upgrade manager. Okay, so this is a big one. So this is the list of all our upgrades. Again, in practice, this might load up, I was going to say from a text file. And in practice, it would probably have to incorporate some amount of Lua. But this is of every upgrade that you can purchase here. So the upgrade itself, so this is the upgrade class here. It's got a name, a description, a cost, and a certain action it can run. Upgrade action, this is a delegate. This is basically a pointer to a function. So when you purchase a upgrade, we run this function is what happens. And so when we create our code, so you can see here for this first upgrade, this is for boosting our fire rate over here. Notice that there's no capital letters. The font we're using, the capital letters do like special symbols and stuff. So everything's going to be in lowercase here. So it's fire rate. We get the description of the fire rate. This is its cost, which starts at 1. And then here's its function over here. So this, if you haven't seen this, in C#, do they call this a lambda or something? But this is, if I go and just bring it out over here, right? This over here is a function that looks like void some function, which is player unit p, and then it runs this p dot upgrade fire rate 0.25f. Okay, except we don't actually give it a name. It doesn't have a name of some function. It's just a function that sort of gets created at runtime, and it just gets stored over here so that later on we can just call upgrade action and it'll run that piece of code. And because these are all little one-liners, I wanted very little code written here, so mostly all the work happens in the player itself. It could have happened in the player, it could have happened over here, but basically I didn't want to do a lot of work here. I just wanted to be able to call the right thing for the right function, maybe pass in some parameters. It's quite nice because here it says increase your fire rate of your weapon by 25%, so I put in 25. If I decide to change the buff to like, oh, let's make it, I don't know, 10%, then I'll be like, right, so right here, as opposed to going to another file, I can change it to 10%. And this is quite nice later on if instead of being, some C#, like this is a function in C#, the start function here, that generates all these upgrades, this could instead, in start, could be something like read from the upgrade text /xml/lua/ whatever file, right, to define what the upgrades are. So that's that. So we have this list of upgrades over here that defines all the possible upgrades. A couple of them are funky because, for example, when you purchase your first auto drone, first of all, it tells the player, hey, you have an extra drone, but then it also calls add drone upgrades because drones can be upgraded to have more armor and fire rate and damage, and it wouldn't make sense for these to show up in the list of upgrades before I have a drone, right? You get to shop for the first time and it offers to increase your drone damage, and you're like, but I don't have a drone. So these get added in after you purchase it for the first time, which works quite nice, don't you think? We could also remove some of these if we wanted to. Like if something's supposed to be a one-shot upgrade, we could do that. When we actually purchase an upgrade, So right here, purchase upgrade, we tell it which upgrade we're purchasing. So what we do is we go to the player, we make sure the player can afford the upgrade. If so, we play a sound effect, we charge the player by removing his health, because again, the theme of this particular Ludum Dare was your life is currency, so it costs you health to purchase this. Then the cost of the upgrade goes up. Currently, yeah, we're doubling the cost, so we don't really need the ceiling to int, but we're experimenting with different things. So the cost of the upgrade doubles every time you buy it. So it costs 1, then 2, then 4, then 8, then 16, and so on. And then we actually run the upgrade action, right? Upgrade.upgrade action. We just pass the player unit. Done, done, done. So that's how upgrades work. And doing it this way is so nice and flexible, really easy to have one big list. We've used this sort of mechanic in tons of games, and it just is super easy to iterate on. Add more upgrades. You want to invent a new upgrade, just add it in. Like if there was defense drones, right? Add it in here and just, make sure that defense drones are a thing with some sort of behavior. Done. This is the upgrade window code. Not terribly interesting, but what it does is it shuffles the list of upgrades over here, and yeah, every time you reroll, the cost goes up, and it just shows, so we're setting up the button over here. So this is where we set the button text based on what upgrades we rolled, and then when you click the button, so upgrade button clicked, we check to make sure that the player can afford it, and then we say, yeah, upgrade manager, you can purchase the upgrade, and then we re-randomize that one button over there. Easy peasy. This is just to make it so that we can shuffle a list very easily. Okay, weapon slot. A bit more code going over here. So players and enemies have weapon slots on them. Weapon slots keep track of the cooldown. Basically, they are responsible for knowing whether or not you can shoot a bullet right now. And they have a bullet prefab. When you shoot, it just spawns the bullet prefab and gives it the appropriate sort of like direction, the movement over here. Oh yeah, there's a little gizmo. When we look at the player object in the editor over here, see this little yellow ball over here? This is the place where we shoot from. So we have like a vector. Right, the actual weapon slot and stuff like that. We have some positions and things like that. This offset is where the bullets actually come out of when the player or the enemy is shooting, so we can have it spawn in an appropriate area, and we get a little preview with a yellow dot. Very handy to do this. This doesn't exist in the game. It's only in the editor that you see this. So on update over here, we basically just, weapon cooldown. So, we have a fire rate that we have over there. And only the player has a heat effect, but we bring the actual heat down between firing rate, and we do various effects and things like that on the player. So the big thing here is fire. So the player, when you're holding the space bar, or an enemy, every single frame is basically trying to fire. We check to see, can we fire? If not, just return. If we can, then we play the sound effect, we do the heat calculations, we update our various cooldowns for shooting rate and whatever. But ultimately what we're doing over here is we are spawning a bullet. If a multi-shot is 0, we just spawn a bullet. Otherwise, on a multi-shot situation, we do some various angle calculations to make the multi-shot look really good, and then we spawn a number of bullets. And here's where we actually spawn the bullet. We have this weird thing, whether an enemy is facing left or right. This could be cleaned up in a million different ways. It was awkward, but we're just getting it working very quickly with a bunch of little hacky things to get things working. But yeah, and when we actually spawn a bullet, the weapon slot is the thing that knows how much damage the bullets are supposed to do, or at least bonus damage, right? If you have upgrades and things like that for like damage, piercing, homing rate, and criticals and things like that, we pass that information to the bullet from the weapon slot. So when you upgrade the player updates its weapon slots and says, here, now you do bonus damage, and then whenever the weapon slot fires a bullet, it transfers that information over to the bullet itself. We rotate the bullet to face the correct way for the player and for multi-shots and whatever, and there we go. Done, done, done. Weapon slot enabler. I don't think this does anything. It turns weapon slots on. Oh, I think this is for the boss. This is what turns the central core's weapons on when its children are gone, I think. And that's that. Oh, and we have a few pieces of code that aren't actually in the script folder, which is not great. This is the thing that flashes the damage. Basically, so this is the player. When you take damage, it flashes screen red. All it does is it starts a countdown timer and either turns the alpha on or sets it to 0, on, off. That's all, with some various little timers. Delete sound. This is whenever we play a sound effect, I guess we should talk about the sound manager. Let me jump over to the sound manager here first. So this is the sound manager. It has a bunch of things in the inspector that we can load up these arrays for various sound effects. These are arrays because we can have multiple different sounds, so we have some nice variation, which tends to sound really good. And so what happens here is, let's say we want to play a sound effect. Like every time we shoot, either we or the enemy shoots, we go play pew, 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 pew kind of thing. So it grabs a random sound from our pews list. It creates a new audio source and sets the audio source's clip to this. So creating new audio source, we create a new game object, make it a child of our sound manager just to keep things clean. We give it an audio source component. We return that audio source so we can assign the clip. And so this spawns it. So inside a sound manager, it instantiates a new object, plays a sound effect, and then goes away at that point. And yeah, it just cleans itself up. Easy peasy. So the delete sound over here waits for the sound effect to be done playing. It has a few catches because when you do something like audio source.play, it actually only starts playing on the next frame. You're telling it on the next frame, start playing the sound effect. And so you have to wait one frame because otherwise is playing returns false immediately. So it does a funky thing over here. So we sort of delay and do some stuff. Anyway, and then at some point over here, so there's a return, but at some point here we check to see is it's playing, it's equal to false. Then we just despawn this object and clean things up. Detach from parent, this is just a little utility script. All it does is at the start of executing, it just stops being attached to its parent. Like, I don't remember what we were using this for. Maybe it was drones? No, I don't remember. But it was useful. This is to have a piece. Oh yeah, this is with detach from parent. This is to have something follow another target over here, to follow its parent. What it does is, this was for our text that follows the scrap at the start of the game, right? Boom. Because the scrap at the start of the game, all the scrap rotates, right? Spins, which looks really nice. So if we want this text to follow the thing, the text spawns in, it's a child of this scrap. But if we left it that way, the text would be spinning around and around and around the object and basically be impossible to read. So we have it on its start, we have it detach itself from its parent over here. Remember what its offset location was. Detaches it and then it just follows it. It remembers what its parent was and it just follows it. So it stays in the same position without being a child of that. We have our music manager over here, which is very simple. It's got audio clips for songs. It waits for a song to stop playing and then plays the next song in the list. This is attached to the go to next scene button. This is basically in our main menu. When we hit start, we just call go to next scene and it just goes to next scene. Our quit button, that's it. Our restart button is over here. We just looked at sound manager. Oh, here's our teleport effects. So the little ovals in our list. So when we hit play, the teleport effect is a bunch of these little graphics and they fade in. And that's all this is. This gives them a random color, a random rotation, and then spins them around either forward or backwards. That's it. And then our tutorial group over here. This is when we have a tutorial pop up, this thing listens for a mouse button click and then shuts the tutorial window. And that is the entirety of the code to run this game. What was that? Just over an hour. Ooh, a little longer than I'd hoped, but I guess we had a fair amount to talk about. Yeah, I don't know. Sort of covers it. 40 hours. One went good and one went wrong. I think things went overall pretty good. There was a lot of little... My standard for things that, like, I consider, like, should be clean and proper in a game are relatively high for LUDUM Dare things, which is why there may not be as much variation in content as I would have, overall liked in here. But we spent a lot of time just making sure things ran really good and we were happy with that. And that was okay. And, it's not the world's most creative game, but two things. One, it turns out to be quite fun and addictive to play, which is a huge... My primary goal is always fun, but it was also a really good sort of tutorial project like here. Easy to sort of explain people. People can grow up. We were answering a lot of questions about programming while we were doing the stream, so it was good to aim for something that was relatively simple and manageable so we could spend more time explaining things. But there's still a lot of stuff going on here. And what's great is, like, at this point, if you want to make the game way more varied, all you have to do is, draw some more spaceships, make some more enemy prefabs, and use them in your level, right? In your level setup over here. That's it. Just make more different levels. That's it. We have code for multi-stage bosses. We haven't actually looked at the bosses. What I can do here. There, level just boss. if I do this, so we did this just for testing, then our first level will just be a single boss. So we can show that. Yeah, bullet time, drones. Oh, this is 2 bosses.
Game over.
All right, that was pretty hard. So I didn't actually get to show it. But these bosses here, you can knock off each arm, the top arm, the bottom arm over here, and then you have to deal with its central core. And yeah, so boom, boom over here. Maybe I should have made level just boss be a single boss for testing. But yeah, I mean, it's very easy to add more multi-stage bosses. You can, we only have 2 bullet prefabs, one for the player and one for the enemy. So there's a generic bullet here for enemies, which are in yellow, and the bullet for the player, which are in white. And you can have more of them. You can have things that look like missiles. You can have things that look like lasers. And boom, all of a sudden you've got a game with a ton more variation. You see how easy it is to create new updates, right? You just go to the, or upgrades, I should say. You just go to the upgrade manager, add more upgrades over here, and boom, Bob's your uncle. Easy peasy. So really, really good bones to this program. And again, fun and challenging to play as is. If you got any questions, leave them in the comment. Send me a tweet. Do whatever. Thanks for watching. Thanks for supporting the channel. I'll see you guys next time. Bye-bye.